Alright, dimensional analysis. Here's another one of our Chemistry lessons, and this one is extremely important that you study as many times as possible to make sure that you can get this down. Dimensional analysis is nothing more than a way to convert from one unit to another, whether you're converting metric units to metric units or chemical substance to another type of chemical substance, which we do constantly in this class. It is very important, as I said before, for you to learn this system because you're going to be relying on it heavily in the second semester. This is one of the main reasons that students fail college chemistry. Take a look at what we have here. To use dimensional analysis, we have to use what we have as conversion factors. You've been using them all your life, you just probably haven't heard them in that term. An example would be that 12 inches is the same as 1 foot. Well, the conversion factor is that 12 inches is 1 foot. Or I could write it this way: 1 foot is 12 inches. That's a conversion factor, and we can flip that up and down depending on which way we want to use it, because we want to put on top either this one or this one depending on how our problem is going. Which one we want to go to is the one we want to be placed on top. So here's a problem. How many feet are in 100 inches? So when you have a problem like this, the first thing that you want to do is to be able to write down what you have. So I have 1,000, inches. And they want me to figure out how many feet. Well, in our last conversion factor, we know that there are 12 inches for every foot. So I want to go to feet, so I would put feet on top. 12 inches. And then I would cross-cancel all the like terms. In this term, the inches are like terms, leaving me with just the foot left, which means that's what my problem asked. I know I'm on the right track. And then if we take and we divide 1,000 by 12, we end up showing that's about 83.3 feet. Okay? Then that would be our answer, which we would then box. Okay? This is basically how you would do dimensional analysis, is to create conversion factors. Now you're going to sit there and say, well, this is very simple, Mr. Staten. So let's take a look at another. Okay. Now here's another one. Because you never learned dimensional analysis well, you have been working at a fast food restaurant for the past 35 years wrapping hamburgers. Each hour you wrap 184 hamburgers. You work 8 hours per day. You work 5 days per week, and you get paid every 2 weeks with a salary of $840.34. How many hamburgers will you have to wrap to make your first $1 million? Okay, so you can pause this now and write this problem down so you can then sit there and try to work on it. And on the last page, I will go ahead and show you how we'll get it going. Now, one of the reasons why you need to make sure that you can do this is because in the second part of chemistry, in the second semester, you have a mandatory pass exam, which you have to pass to get credit for the class, that covers on stoichiometry. Okay? And stoichiometry, as I said, is one of the most difficult parts that kids always have problems with. It's actually fairly simple, and once kids pass it, they go, wow, why didn't I get that before? But it's mostly because you thought, I can do this a better way, my math teachers taught me how to do it a better way, and then you don't learn how to do dimensional analysis by laying it all out, and when you get to the second part, you struggle. Okay? So if you learn it the way we teach you to at the start, you should be fine. Now here's a very simple problem. As it says, a chemist combined 116.9 grams of potassium nitrate with excess aluminum hydroxide. How many grams of potassium hydroxide can be made? Well, to do this, the first thing we're going to have to do is create a chemical equation and talk about molar mass. And there might be several things that you have not actually learned yet, so don't get frustrated. This is just an example of why we actually have to go about and do this. So the first thing I need to do is create a chemical equation. So I have my potassium nitrate, and it's combined with aluminum hydroxide. And that's going to create aluminum nitrate plus potassium hydroxide. Now we'd have to go through and balance this, and then we'd see, okay, how many do we have on each one? And when we get done balancing this, we're going to see that we're going to need a 3 here and a 3 here. But that's a lesson for a different time. So there's our balanced chemical equation. Now, what we need to basically be able to do then is to go about and to try to get this thing taken care of. I have 116.9 grams of my potassium nitrate here, and I would have to look at my periodic table and figure out that 1 mole of potassium nitrate, according to the periodic table, is going to weigh 101.1 grams. And then once I'm done with that, I then have to then say, okay, I've taken this and turned it from grams to moles. Now I can use my balanced chemical equation and say, here's my next conversion factor. 3 moles of potassium hydroxide will create, or can be created from, 3 moles of potassium nitrate. And then it wants me to turn it back into the grams, so I would then end up getting rid of my moles and turning it back into grams, and I know that there are 56, by looking at the periodic table, 56.1 grams of potassium hydroxide for every 1 mole of potassium hydroxide. So I now have just gone through and used all of my conversion factors. This is 1 mole of KNO3, we'll put that right there. So then I want to go through and I want to cross-cancel all my like terms. Well, grams and grams, it's above and below. Potassium nitrate, I got potassium hydroxide. So I'm left with just this potassium hydroxide, which means that's what they asked me for. I must be in the right track. If I take my numbers then and go through them one at a time, anything that's on top, as in like, take this number, 116.9 times 1, then divide that by this number, then multiply that section by this, divide by this, then multiply by this, divide by this, and I will show that I end up with about 65 grams, but we'll put it in here, 64.87 grams of potassium hydroxide. Now, while there's a good, possibility that you didn't understand the balancing the chemical equation, how to determine what products are actually going to be created here and stuff, that's not the point. The point is that you need to make sure you can learn dimensional analysis and how to set this up, because this is what you're going to have to do when you get to the second semester. And if you can't do this, you do not get credit for the class. And it's not that hard if you just follow the steps. Now, about that problem we talked about a minute ago, let's see what you got. If you got the right answer, then you should have ended up with 17,516,719.42 hamburgers is how much you would have had to have wrapped to make your $1 million. The conversion factors that you should have come up with was that you needed to start with $1 million, so I'm just going to put that in shorthand here and just say $1 million. And then my conversion factors I went through was that I had 184 hamburgers per hour. I then ended up working 8 hours per day. I worked 5 days per week. For every 2 weeks, I got $840.34. Then if I go through and cross cancel, okay, I got my $sign, $sign. Everything that's above and below the number line that you learned in mathematics can be canceled out. Then I go through and do my math, multiply all of these that are up here along the top. 1 times 184 times 8 times 5 times 2. Take that number because everything's divided by 1 here, and divide by this, and you should end up, as we said, 17,516,719.42 hamburgers. Please review this as many times as you need. This is an extremely important process that you need to understand, okay? If you don't understand it, come in and ask questions, okay? Remember, chem is try. You cannot give up. You keep trying and trying and trying, okay, until you get it done. And stay gritty out there.